All right, hey, we're looking at 2-5 today. We're gonna do some equations, solving them with our squares or cubes. So we're reviewing, we've got perfect cubes and we got cube roots. So cube refers to 3. If I've got length, width, and height of something, or you've got something that's being multiplied by itself 3 times, so 7 times 7 times 7, that is a cube. And when you go backwards with a cube root, we're looking at what times itself 3 times gets me that. It's very similar to squares and square roots. So we're going with the key concept here. You can use square roots to solve equations involving squares, and you can use cube roots to solve equations using cubes. So here's an example. Janine can use up to 150 1-inch blocks to build a solid cube-shaped model. So it's cube, so all 3 sides are going to be the same length. So this side, that side, and this side, they're all going to be the same. And we can use the same variable to show that. So S. What are the dimensions of the possible models that she can build? How many blocks would Janine use for each model? So possible dimensions could be some things that are going to equal up to be 150 when I multiply them together. So something like, so it's got to be a cubed shape. So it means that it has to be, again, all 3 sides have to be equal. So we can't have something like 5 times 10 times 3. That's not possible because those are not equal numbers. So we have to figure out what is something that we can do with the 3 of those. So what S times S times S is going to equal 150. And so when we look at those together, we can figure out that S times S times S, if we take the cube root of all of those, with the little 3 up there means the cube. When we're doing equations, we can do stuff to the equations to help us out here. Whatever you do to one side, you have to do to the other one to help solve an equation. So if I'm going to put a cube root on my left side here, I have to do that on the right side of my equation as well. And so these 3 S's, this is also like, this is for S cubed because I have S times S times S. So these cube roots are going to cancel each other out there. They're going to cancel out. So I am left with S is equal to the cube root of 150. Now that's not a perfect cube, so we can just leave it like that. If I were to punch that in my calculator, it would give me some irrational number that I cannot write out. So that gives me, you can see it there, it's 5.31, all of that. That is an irrational number. So I can leave it as the cube root of 150. All right, so here's a diagram. Example 1. Darius is restoring a square tabletop. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will he need? So he's restoring a square tabletop, wants to finish the outside edges with that, with the decorative molding. So that's the outside edges. So that means if we're looking at our area here, we have to figure out, well, what are the lengths of our sides here? So area is calculated by length times width. Does this say it's a square tabletop? So S is going to be the same there. So that means S squared, because length times width gives you the area. So in this case, S times S is equal to 25 feet squared. So I can solve this using square roots. So S times S, that means S squared is equal to 25. I can get this s by itself, and that is going to solve the equation and let me know what my side is equal to. I can do that by taking the square root of this side, and that's going to cancel out the squares, so I'm left with just s. So the square root of that, what I do to one side, I have to do to the other side. So s is equal to the square root of 25, which we know that it is 25 is a perfect square. Means that when I calculate the square root of 25, I get a nice round whole number. Square root of 25 is 5. So that means that my sides here are 5 feet. So s is equal to 5 feet. But we're going to do a decorative molding around the outside of this. So perimeter is just adding up all the sides. So 5 times, or plus 5 plus 5 plus 5, or 5 4 times, so 4 times 5. Our answer there is going to be 20. So if I'm going to do a decorative molding around this piece of woodwork, my decorative molding, I need to buy 20 feet of it. And that's pretty much what I all did there with all those questions. Kyle. Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions for that screen? So here's an opening in the front. He wants to cover that with a square, with a screen mesh. So we need to figure out what is this side, what is this side, and as a result of that, we'll have to figure out what is this one as well. So s times s times s is going to equal 343 square feet. So that's the same thing as saying s cubed equals 343. So if we take the cube root of that, cube root of 343, our s is going to be equal to, let me do the calculation, cube root of 343, the answer is 7. So that means that 7 times 7 times 7 equals that. So s is equal to 7. So that means that my screen here is going to have to be 7 feet. Holy cow, that's big. By 7 feet. Let's calculate that. Last one, solve equations involving perfect squares and cubes. So we have x squared is equal to 50. Our goal is to get each of these by themselves, and we are going to do something to them to cancel out what is already being done to them. So this is x squared equals 50. To get the x by itself is our goal. So what we're going to do is take the square root of that. That's going to make these squares cancel out. What we do to one side, we have to do to the other side. So x, because it's by itself now, is equal to square root of 50. Now I know off the top of my head that that is not going to be close to, that's not a perfect square. So I'm going to leave it as that. If I needed to estimate it though, this right here is not part of this, it's going above and beyond. But if I wanted to estimate it, I know that 7 squared is 49. So the square root of 49 or 7. And then the next one, so 8, is the square root of 64. So I know that the square root of 49 is greater than the square root of 50, which is greater than the square root of, or less than the square root of 64. So x. So x is between 7 and 8. If I had to estimate, I would say it's probably going to be like 7.1 something, because it is really close to that. So I'm going to say x is equal to the square root of 50. This right here just proves that it's between 7 and 8. I can't get the exact number. It is irrational. If I punch it into a calculator, it's going to be another decimal that goes on forever. So answer there is x equals square root of 50. Next one, we have x cubed equals 37. We want to get x by itself, so we're going to take the cube root of x, and we're going to take the cube root of 37. Over here, this is all going to cancel out, and so we are left with x. And again, this 37, the closest cube roots to that, oh wait, no, drawing a blank. Cube root of 1 times 1 times 1 equals 1. 2, the cube root of, or 2 cubed is 8. 3 cubed is 27. 3 times 3 is 9, times 3 is 27. 4 cubed, 16 times 4 is 54. So I know that 37 is not one of these perfect cubes, and so I can leave it as that. X is equal to the cube root of 37. That's a good marker. I have to keep that.